session possible to present it out there over you to you guys. So without further ado, let's just get into the session. I usually just thought about who am I, why am I qualified to present on animations, and yeah, there are many points over here. And Said, I believe he already made a great intro for me, but I'm just gonna sum it up as when I started using SolidWorks back when I was 14, I was still a kid back then. I didn't really have any intention of using it as a mechanical design tool. So for me, it was just another software that I'm learning to use in general. And because of that, I started using SolidWorks in ways different than what usual engineers would use SolidWorks for, including animations, for example. So this is the whole idea of what this use of SolidWorks came from. Why did I decide to really get involved into the motion studies aspect of SolidWorks? It became apparent that this software is really powerful in many different areas, and one of the areas that really got my attention at that young age was animations. So really quick, if you don't know the core podcast, Kirby and Johnny, these two gentlemen from England, they're also user group leaders, and they have a podcast that they host every now and then on their YouTube channel called the Core Podcast, where they talk about different things about the SolidWorks community. And I was a guest on their podcast a while ago. So if you'd like to know a bit more about my background with SolidWorks, you can go and check the podcast we have together over there. So let's start about what we're going to talk about today. And we're going to take it from the very beginning. What even are motion studies and why they're important? Why should one even consider learning them and using them? And then we're going to talk about the different types of motion studies out there. There are multiple types. We're going to talk about each type, why it differs from the others, when should we choose it, and so on. And then we're going to take each type of them and discuss it a bit more
Yeah.
into detail.
Yep.
We're going to talk about the different techniques that each type has and how we could use those techniques to create a cool animation. And at the very end, we're going to talk about how to take your animation from SolidWorks and present it to someone if you want to like share it on social media or something like that, and the process that goes into doing so. So for starters, why should we even use motion studies? And there are three things that come to mind when I ask myself that question. And the first thing is it's eye-catching. You know, anyone can create a cool design, but the way you present the design is what matters. So let's say, for example, I've got this animation over here of the lantern. It's a cool design. You know, it's not really spectacular in any way, shape, or form. It's just like a laser cut lantern, couple of pieces patterned together and mated together, and that's it. But when I want to present it to you in a cool, eye-catchy way, the best thing to do is using animations. And if you don't believe me, well, this animation was really cool that the Soul Systems actually featured it multiple times on their social media channels, and it got like tens of thousands of views. So it's the same design. You know, I can just share a screenshot or share the Soul file with you. But when you see it like with this movement and this exploded view and this rotation and all of these aspects combined together, it gives you another dimension of viewing the model. Okay. And the other reason is some designs, you won't even understand what they do or why you would need them until you actually see them in motion. So for example, this mechanism you have on screen right now, just as it says like that, still you might not understand what it does until you actually see it in motion. And that's when you realize that, okay, so you've got these three axes, they rotate in the same direction and they convert rotary motion to reciprocating linear motion. So only when you see it in motion do you understand what that mechanism actually does. And the third thing is sometimes seeing your model from a single view isn't enough. So maybe your model has intricate details that you need to zoom in to be able to see a bit more clearly. Or maybe it's got certain design elements on a different side of it that you need to move to that side and be able to view it from over there and so on. So seeing it from a single static view might not always be the best option in this case. Okay. So these are the three main things, but there's another aspect, which is to have fun, right? So as I said, this whole session is not really it is going to be technical, but there's always going to be this fun element that we're going to consider all the time, because after all, the main goal here is to be able to present your work in the best way possible, viewing wise, like visually pleasing. So this, for example, this video was created inside of SolidWorks. After Effects, I didn't use Windows Movie Maker or Adobe Premiere. Everything was inside of SolidWorks. And if you don't believe me, here's a side-by-side of how I actually created it. So I got this screenshot, I put it inside of SolidWorks on a boss extrusion as a decal, but the camera started moving the camera around and then zooming in a bit over here and there it is. So obviously, when the developers of SolidWorks introduced motion studies, they didn't have this use case in mind, but knowing that it can create something like this can give you a better idea of what this tool is capable of. And if it can do something as silly as this, then definitely can do something a bit more intricate and advanced. Okay, so now let's talk about the different types of motion studies out there. We're only going to cover two of them today, animation and basic motion, but know that there's a third type, which is motion analysis. We're not going to talk about that today because motion analysis, first, it doesn't come with every edition of SolidWorks, unlike animation and basic motion. So whether you've got SolidWorks Standard, Premium, Professional, Ultimate, if you've got SolidWorks Desktop or Connected, if you've got a student edition, a commercial license, whatever, you always have animation and basic motion. But motion analysis only comes with SolidWorks Premium. And if you're using SolidWorks Connected Premium, you'd need also another add-in, another 3D experience role to go with that to be able to use motion analysis. And the other reason is that motion analysis starts like crossing the line between an animation and becoming like a simulation. It's got more simulating elements into it than animation and basic motion. So that's why it's like a different topic altogether. Okay. So now let's talk about the difference between both. Let's start with animation. So animation, there are different types of creating an animation depending on what it's based on. So the first thing is if it's based on something called a key point. And you can think of a key point as like a still moment in time. Like if you have your model and you like take a screenshot of it, and then you do some edits and take another screenshot of it, and you tell the software, okay, this first screenshot and the second screenshot, these are the key points, and I want you to move from the first key point to the second one. That movement or that transition from one key point to the other is called interpolation. And this is the whole thing that you're going to do. You're just going to create key points and tell the software to do some interpolation between those key points, and that's it. The other type is based on motors, where you provide a motor and you set the parameters of the motor. And okay, I want this motor to rotate in this direction with this speed, maybe speed up a bit here and slow down after some time and so on. I want it to be attached to this component and so on, and then hit calculate and it runs it for you. Okay. When it comes to basic motion, it's not like motion analysis, but it does have some simulation in it. So it's based on a different simulating engine, but it's got some physics baked into it. So let's say, for example, you want to simulate contact between different components, or like collision where something hits something else and then it moves it or pushes it forwards and so on. Or maybe you want to simulate something like gravity, things that you would find in real life. These are the things that you would need basic motion for. And once again, it's way simpler or faster than motion analysis because it's not as advanced as it is. So it's way quicker and faster when it comes to computation when compared to motion analysis. So that's a lot of talk. What's the conclusion here? Well, the main thing to know is when to use each. So when it comes to animation, you already know the inputs and the outputs because you've already provided the software with all the key points. So that's the starting position and the ending position and any positions in between. You already told the software everything. All you're asking the software to do is just show you how that movement from one position to the other is going to look like. Okay, when it comes to basic motion, it's a bit different because you provide the software with the parameters, with the boundary conditions, and you tell it to simulate that for you and run the simulation for you, and then show you how everything is going to be. Okay, so that's the main difference between both of those. So now let's talk about animation in a bit more detail. So we started by talking about interpolation, and we said that interpolation, or like this transition from one mode to the other, is based on key points. Now let's talk about the different types of key points out there and the different types of interpolation modes. So let's imagine that we've got these 5 boxes all on the left side here, and then we've got them all on the right side over here. So this is the first key point, and this is the second key point. And what I want the software to do is to transition from this first key point to the second key point, and that's pretty much it. But the way it transitions can differ, and there are 5 types of interpolation modes inside of SolidWorks. Okay, let's run them in full screen over here. So look at the 5 boxes and see how they move from the left side to the right side. So you've got the linear, which is just like constant speed all the time. Snap, it doesn't change until at the very last moment. Ease in and ease out. The difference is that it speeds up in the beginning and then slows down at the end, or the opposite, slows down at the beginning and then speeds up at the end. And ease in / ease out, it slows down in the beginning, speeds up in the middle, and then slows down back at the end. So as you can see, all of these 5 different interpolation types, they changed from the same 2 key points, from the beginning key point all on the left to the end key point all on the right. That didn't change. All that changed is how it went from the first key point to the second key point. Okay, so once again, you've got linear, that's like no change in speed, constant speed. Snap is really interesting because it's got no movement whatsoever till at the very last moment, and it just snaps into place. Okay, so these are the different types of interpolation out there. Now let's talk about the animation techniques. Okay, so let's start with what's based on key points. This is the animation that we want to create right now. It's going to be an animation of this chocolate bar. And if you don't know this animation, let me just show it real quick. So it's an infamous illusion where you would change or shuffle where these chocolate pieces are after cutting them in a certain way, and then somehow you end up with an extra piece of chocolate. Maybe you've seen it before, maybe you've not. Anyways, this is the animation that we want to recreate right now inside of SolidWorks. So let's jump back into SolidWorks. We've got the assembly over here, and now let's start by creating new motion study. And once again, we're going to do it by basic dragging, just by the cursor. Okay, this is the simplest form of creating an animation. So when I started a new motion study, I've got this area at the bottom over here. This is the motion manager. Okay, I can collapse it from the arrow over here or expand it once again. And over here on the right, I've got the timeline where it's like divided by time, 0 seconds, 2 seconds, 4 seconds, and so on. And I've got some tools at the top, and I've also got like a stripped down version of the feature tree here on the left. So this is the feature tree that we're used to. You know, it's got planes, it's got the components, it's got the mates and everything. But this one, it's a bit different because it only has the things that you would need to control inside of the animation. Okay, so for example, you've got the lights and cameras and scenes. Okay, you've got the components, but here you don't find the features. You'd find moving, exploding, changing the appearance, and so on. And you've also got the mates, just in case you want to control those mates as well. So you won't find anything but the things that you'd actually need to use inside of the animation. The next thing is, you see this bar over here, highlighted in orange right now. This is the time bar, and it tells you right now, where are you in time? So let's say, for example, I jump to 2 seconds. I click over here. The time bar jumps to 2 seconds. Now, if I do any change, that would introduce a key point to that time. So let's say I would grab this component and drag it all the way down and then release. As I release, I see this key point added over here, this rhombus shape. So this is the key point added at 2 second mark. Okay, and this green bar over here, it's called the change bar, which indicates that there's a difference between this key point and this key point. They're not the same key point. Okay, so if I hit calculate, okay, notice that this area over here, it's still gray. That means that it's not calculated yet. If I hit calculate, it starts turning into yellow, and that means that it is now calculated. So now if I hit play once again, as you can see, this component is moving downwards. And if I place the time bar at any position in, let's say, for example, at 1 second, it tells me, okay, this is how it's going to look like at that time. Okay, so I can drag by the time bar to see at various times. Okay, let me just zoom in a bit. Maybe zoom in a bit more, something like that. So I've got at 0 seconds and at 2 seconds. Let's keep going. So let's say at 4 seconds, I want this component to be dragged all the way over here to the right. Once again, if I hit calculate, it's going to calculate the downwards movement and then the right movement. Okay. And now what I want is for this big part to come over here to the left at the same time. So while this is moving from 2 to 4, I want this to move this way. So at the 4-second mark, I want this to be dragged all the way over here. And as you can see, I've got this key point. But there's something really interesting here. You know, the change bar is going all the way from the 0-second to the 4-second mark. What that means is when I hit calculate, this will start moving inside and this will have some interference while this is happening. So what I want this to do is not to move until after the small part moves all the way down vertically. So instead of this moving from 0 seconds to 4 seconds, I want it to only move from 2 seconds to 4 seconds. The way I can do that is just drag this key point all the way to the 2-second mark, just like that. Okay, so now the change is only going to happen from the 2-second mark to the 4-second mark. If I hit calculate once again, it's going to wait until this comes down, and then while this moves to the left, this is going to move to the right. And I can keep going on and on. So at the 6-second mark, I would like this component to move all the way down, maybe somewhere like this. Okay, and I've got also the key point for that. And while it's hidden over here, I would like this delete me component. I've called it delete me just to remember it. I want this to be hidden as well. And also the same thing, I also want it to be hidden from the 2-second mark to the 4-second mark. Now I've got the animation ready. So let me just collapse this and hit calculate from the beginning. So this moves downwards, this moves to the left, and this moves to the right, and then this comes downwards, and you won't see this deleted part just as in the original illusion. And everything looks cool and everything. It didn't take that much time to create it. But if I inspect it a bit closely, you find that since I'm doing everything based on my hand, my cursor, there's some interference happening over here. It's not really precise. And the other issue is, let's say, for example, I don't want this chocolate bar to have five pieces horizontally. Maybe I want it to have only 4. So if I update the model, will this motion study update with it as well? Well, probably not, because the dimensions are probably going to change. And in that case, what I would like to do is to have everything linked with mates. So not just being based on mouse movement, but to have mates as well. So I'm going to go back again to the model view. It's the same model. I'm not going to change anything. I'm just going to create a new motion study, or I can just right click over here and hit create no motion study. Both are fine. What I'm going to do right now is to make everything based on mates, since I already have the assembly assembled and I already have the mates in place. So I've got some limit distance mates over here. And a limit distance mate, if you don't know what it is, all it does is just you provide it with a minimum and maximum value, and it can move freely between those two values. Okay, so what I want to do over here is to stop at the 2-second mark and then right click on this limit distance mate and edit dimension. Okay, and now I've got this dimension box. I can just enter a numeric value, and then I also have the same thing. I'm going to have a key point, as you can see over here, and the same thing is going to happen. So if I hit calculate, it's also going to move downwards and everything. But right now I've got a number, I've got a value, a numeric value to control how everything is based. So this is the power of using mates. So I can come over here at the 4-second mark, and then I would change this horizontal value. But remember what we did last time? You had to create it, move it, and that wasn't really cool. So maybe I can actually come over here and take this key point as it is, Control C to copy, come at the 2-second mark, Control V to paste. And you don't see any change bar over here because this key point is the exact same as this key point. There is no change, so there is no change bar, right? But if I go to the 4-second mark and I double click on the distance and I change this to 40, I hit OK. Now I would see a change bar from the 2-second mark to the 4-second mark. It's the same thing, just a different way to create it. And once again, if I hit calculate, you would notice this goes down and this moves to the left, or to the right, and so on. So I can keep doing this one step at a time. But right now, I've got really precise control over everything. So once again, at the 2-second mark, I want this big component over here to also not change. And then at the 4-second mark, I'm going to double click on the distance and change that value like that. And now and the final thing is to come at the 6-second mark and to change once again this value. So I'm going to copy this and paste it at the 4 because I don't want any change from 2 to 4. And then at the 6-second mark, I'm going to change this once again to, and this time I know exactly that it has to be 43.75 millimeters because I used the measure tool beforehand to measure exactly where it should be. And based on that, now I know precisely that when I hit calculate, This is going to move downwards. This is going to move to the left and this to the right. And this is going to come over here exactly where I need it to be. And if I zoom in a bit over here, you won't find any interference whatsoever because everything is based on a number, on a value. The last thing I should do is just come over here at the 4-second lock and just hide this component, this delete me. And yeah, that's pretty much it. Now I've got the exact same animation, but the only difference here is that everything is now fixed with a number, with a numeric value, with the dimensions that I've baked into it through the mate over here. So the end result is the same. The only difference is how I reach that result and what could happen if I maybe edit the design along the line in the future. Okay, so that's with basic dragon and with mates. I hope that's really clear. Now let's talk about something else with camera movement. Okay, so what we did right now, that was animating an assembly. Okay, but that's not only what you can animate inside of SolidWorks. You can also animate components or like parts. So this is the part file, not an assembly, as you can see over here. And I would like to animate this. Since there's not going to be any movement in this, it's just a part. I'm going to animate the orientation, where I'm looking at the model from. So what I want to do is, let me just go to the motion study over here. I already have a motion study, so I'm just going to right click and create a new one. And what I want to do is I want to look at it from this area. Let me just maybe zoom in a bit like that. And then at the, let's say the 2-second lock, I want it to jump to this area. But for some reason, I don't find any key points getting added over here. And the reason is, by default, view keys, which are key points for views or for orientation, they are by default disabled. Because maybe you just want to zoom in to select something or to look at your model from a different angle or something. Maybe you don't actually want to change where it is. You just want to manipulate the model just to be able to see it and navigate. So how do you differ? How do you differentiate for SolidWorks? Well, if you right click on orientation and camera views, you see this disable view key creation option. This is on by default, so it's disabled by default. If I turn it off, this key point is now saved. If I come over here to the 0-second lock, and let's say, for example, I want to zoom in a bit more. No, not like that. Maybe something like, maybe like that, okay? And I'm gonna right click and say replace key, just to make sure that it has updated the key. Now, if I go to this view, now you see this key point getting added, and I see this white change bar as well. So if I hit play, it's gonna change from this to that, okay? And this doesn't just have to be like a rotation, it can be anything. So I can zoom out a bit, maybe, and maybe do something like that, maybe, if I want to. And now if I play from the beginning, you see, it's just going to switch from one area to the other. But just for the sake of what I'm doing right now, I want this to instead be like that, maybe, and also to zoom in a bit more, maybe like that. Okay, and that looks cool and everything. And now I can just take this key point, copy it, and paste it at the end, so it starts and ends at the same position. And if I go over here to the playback mode, the default is normal, but I can make it loop or reciprocate. So reciprocate going forward and then backwards, but looping means that it's going to keep playing on and on again. So if I play from the beginning, it's going to go from Yahya to Kedge, back again to Yahya, and back again to Kedge, and so on. It's going to keep doing this over and over and over till infinity. And that looks really cool, but you see this transition from the first key point to the second, and from the second to the third. It's like a sudden stop, you know, from Yahya to Kedge and back. It's like there's this jolt in it, and I want it to be like a smooth animation. So to do that, it's not going to change anything about the key point itself. It's only going to change the interpolation, which we talked about earlier. So if I right click down here, you see the interpolation. The default is linear, so ease in, ease out. Same thing to this one over here, ease in / ease out. Now, if I click from the beginning, it's way smoother, and you don't see that like sudden jolt that we had earlier. Okay, everything is smoother and everything looks like a clean single. Okay, so it's cool and everything, but the same thing, we want some precise movement. So this is everything based on just my panning and zooming with my cursor. What if I want to have some numeric control baked into it as well? So if I go again to the model, open this. Now I'm going to go over here to the display manager. And from here, I'm going to go to scenes and lights and cameras. And that's it. We're going to use a camera. So right click under the camera folder, add a new camera. And now I'm going to have this split screen situation where over here on the right, this is where what the camera sees. This is the camera view. And this one on the left, this is the model view. This Bible and the camera and everything in the scene. And you're going to notice two things here. You see this red dot? This is where the camera is looking at, its target. So when I move this, the camera is fixed in place where it's changing where it's looking at. And this yellow dot over here, this changes where the camera is, so the camera position. But the target is still constant, still the same. So that's how you're going to manipulate your scene. So I can turn on this numeric controls option. I really like doing it because now I've got a target point. I can enter the values, or I can just set it to be to the origin, as you can see. And for the camera position, you can have like Cartesian or spherical coordinates. I like spherical because this value is the distance between the camera and the target. Let's say, for example, 350 millimeters. And then the angle, I want it to be -45. And the elevation to be like, maybe like 5 or something, okay? And I'm going to change it the next time to 45 to go from the other direction. So you see, numeric control makes it way easier for me to do anything. Now, if I want, I can add some camera roll. So look at the camera right now and look what happened. I do some roll, just does like that. Maybe you're going to need this at some point right now. And then you've got perspective. So as you can see over here, yeah, like these lines, they are converging to a point at the lens. I can turn off perspective altogether, and I would have this view. Not really realistic. So in this case, I want to use perspective. And since I'm using perspective, I can change the camera lens. You know, when you have your phone, you've got like the wide angle view, which gets everything in the shot, you and your friends and everything in the background. You've got the telephoto view or the zoom lens, where it just zooms very much into the scene. So you've got lenses, or you can actually change these by yourself. So you can enter like a custom angle and create your own custom lens if you want to. Right now, let's use like this, maybe a bit wide angle. And in that case, let me just zoom in a bit. Let's say 250. Yeah, now I might work, maybe like even 200. And the most important thing here is the aspect ratio. So this is the width to the height. Okay, so the default for some reason is 11 to 8.5. No idea why. Don't use that. Use something like 16 by 9. This is a standard value for like most screens or TVs or laptops and everything. Some even smartphones. And you can also use things like 1:1, which is square format. But in this case, I'm going to go with 16 by 9. There it is. Okay. Not the best positioning of the model right now. I probably would like to just select this and maybe move it a bit to the left. Maybe it's like that, just to make sure that it's actually positioned in the middle of the scene. And since I've got like numeric control, I see that when it's like 0, it's a bit too high. It's 10, it's a bit too low. I can just enter a value of 5 in the middle. This is the power of having numeric control, right? So I'm going to hit OK, and now I've got the motion study. Now, if I go back to this motion study and go back again to the 0 scene, I'm going to delete all of these key points. And to make sure that I'm actually using the camera view, here's the camera view option. It has to be enabled. And when I go to the 2-second mark and right click on the camera over here, change the properties of it. And now all I have to do is just change this value from this value, just change this negative to positive. And since I actually changed this positioning a bit, that's why the angle has changed, but no worries. I'm just going to go with it for now. Hit OK. And now when I copy this one, paste it at the 4-second mark, once again, highlight these two and change the interpolation mode to ease in and ease out. Now, if I play from the very beginning, you see still you have this very smooth end result that you'll end up with. So it's really cool. And once again, having the numeric control makes it really more precise and better to manipulate and to edit along the way. Okay, so that was with regards to mating components and changing the mates, or maybe having a part file and just changing where you look at the part from. There's something else to change, which is appearances. So let's say, for example, you've got a smartphone, and that smartphone comes in different colors. You've got like red, blue, white, and so on. Instead of creating a different animation for every single one of them, you can create a single animation and change the color throughout the animation. So for example, I've got this model over here. Let's just change the, make it something like that maybe. Well, let's keep it like shaded reviews. Got some glitching over here, no worries. So let's say I want to actually see it from the inside. So I'm gonna create a new motion study. And let's say at the 2-second mark, I want to, let's say these 4 pins, these red pins, I want them to get hidden. Okay, so I'm just going to select them all, right click, and then just select hide. So just like that, I'm now hidden them at the 2-second mark. Maybe at the 4-second mark, I want this top half to change the transparency, maybe to make it like semi-transparent. So I'm going to change the transparency. If I recall correctly, this default option makes it like 75% transparent. So maybe I want to like that. I can also make it like start after the previous position. At the 6-second mark, let's say this bottom half, I don't want it to be blue. I want to actually change the appearance altogether. So I can right click and also change the appearance for that. So appearance here. What should we change it into? Since this is SolidWorks, let's go with red. Why not? And instead of plastics, let's go with something really cool. Let's go with like gold. So red gold. No idea why, but why not? Yeah. I'm gonna hit OK. And I'm also going to do the same thing. So also only change it from the 4-second mark to the 6-second mark. And now I want to say for 2 seconds as it is. Don't change anything just so I could see what happened. So I'm just gonna copy this and paste it over here at the 8-second mark. I'm gonna copy all these and paste them at the 8-second mark. Copy this and paste it at the 8-second mark. And then at the 10-second mark, I'm going to take everything from the very beginning and paste it over there. So what happens now is everything changes, it stays still for 2 seconds, and then everything comes back again to the original position at the 10-second mark. Now let's go and see how it's gonna look like. So let me just collapse this. SolidWorks is taking its time, as usual. Ooh, the infamous circle of doom. Anyways, while SolidWorks takes its time to figure this out, this is the idea of it. So you've got changing mates, you've got changing appearances, and you've got changing camera views. You don't have to do each of them separately. You can do all of them in the single animation, in a single timeline. But I'm just showing you each one on its own just to elaborate a bit more on it. But the main goal, once again, is to make use of all of these different tools and techniques to create the best looking animation. Okay, SolidWorks is taking way too long. Let me just close it and run it once again. Yep, thank you. I mean, it can't be a live demo of SolidWorks without actually having like a live crashing of it, right? We have to be authentic all the way. So there it is. So I'm just gonna jump what we created with appearances real quick and move on to the next part. But let me see if I already have a pre-created or pre-existing animation of it. I think I already have one over here. Yeah, I already have one. So this is a similar one where it hides each one of those. Let me just play it full screen. Oh man, it's angry once again. This is one because
So much loading. Happens.
SolidWorks is just adding its touch. Okay, no worries.
Yeah.
I'm going to skip this once again. Maybe it's a bit angry at me today. Anyways, so we now covered all the key points and the different types of animating key points in it. Now let's go with motors. Okay, so let me just check if SolidWorks has it open here. Yep. Okay. So there are two types of motors in SolidWorks. You've got linear motors and you've got rotary motors. A linear motor, or like an actuator, is like a piston or like a screw mechanism. So it's just going to move linearly in a single direction. But remember, just because it's called a motor, that doesn't mean that it actually has to be a real life motor. It just means that you're going to introduce motion in a linear direction, regardless of what that motion is actually based on. So what I mean by that is this. So I've got this model over here. It's like a pressure gauge that's got a spring, and you've got this piston. And then when this piston moves downwards, this pointer changes its position. And if I hit rebuild, this spring pushes it downwards. And if the pressure over here increases, so that's the pointer. And if it pushes it all the way down, that means that pressure over here is at maximum value, and there it is. And the spring is going to cause it to go back up again like that. Okay. Regardless, this is what we want to do. So we want to animate this movement, this spring pushing this piston up and down, up and down. That's linear motion. Obviously, I can create various ways. So please, if you've got your mic open, can you please mute yourself? So once again, this motion, there is no physical motor attached over here. And I can create this using like key points of a motor, or I can also do it with like basic dragging, as we showed earlier, or maybe even with mates, like a limit distance mate. But there's an addition to doing it with motors, and this is what I'm going to show you right now. So I'm going to create a new motion study, and I'm going to add a new motor from this motor property manager over here. Okay, and from here, I'm going to select a linear motor, and the component direction, I'm going to select this face. It's pointing upwards, so I'm going to reverse it to point downwards. And then here it tells me this is where it's going to move relative to. So in this case, this piston is going to move relative to this enclosure. Okay, and then you've got the speed. Okay, so usually people would go with speed and go with, okay, constant speed. This is the velocity. How many millimeters per second? And in this case, I had to do some maths in my head, because I know that this component has to move 31.6 millimeters. Let's say I want it to move in 2 seconds. How do I calculate that in my head? I have to do, okay, 31.6 divided by 2. I don't really like doing maths. So how about we see another option? I can go with distance. I can enter 31.6 as a value for the distance, and then tell it the start time and the end time, and it would do that for me. That's really cool. But once again, I want this to go downwards and then upwards once again. So I don't want to add two motors, or to switch the direction of the motor. I want to do it all in one go. So let's see what other options we have. We've got oscillation. This is exactly what we want, actually, because oscillation, if you don't know, it's like for waves. It goes in one direction and then it returns and comes back to the original position. This is exactly what we want in this case. So all I have to do is just enter the value of the distance, 31.6. And then here is the frequency. Frequency is 1 divided by the time. So I don't have to do any maths in my head. I tell SolidWorks, let's say I wanted to do it in 2 seconds, 1 divided by 2, that's half a hertz. If I wanted to do it in 1 second, 1 divided by 1, that's 1 hertz. If I wanted to do it in 4 seconds, 1 divided by 4, and it's going to calculate it for me, and that's it. But remember, 2 seconds, this is the whole process. This is going and coming back again. So when I hit OK, I've got the motor over here, as you can see. The default duration for any animation is 2 seconds. It's 5 seconds. In this case, I only want it to be 2 seconds. So I can drag this and end the animation at 2 seconds, or I can turn off the motor at the 2 second mark. Either way, let's just hit calculate and see how it goes. It's going to take a bit longer to calculate this one, because at every single frame, this spring component is being rebuilt to its new position. So it's going to take a bit longer, but either way, it's going to end up recreating the animation that I want it to. So during the time from 0 to 1, it's going to go downwards, and then from 1 to 2, it's going to come back again upwards. And that's all with a single motor. I didn't have to do anything other than just add the motors, add the parameters, and call it a day. Okay, so now when you look at it, it's now moving downwards and then moving back again upwards, and so on. Okay, and once, as I said, I can come over here at the 2 second mark, right click on the motor and turn it off if I want to. And in that case, even if this animation is like a bit longer, see there is no orange bar over here. So this motor is now off. It's not gonna run anymore. Okay. And at any time, as you can see, it goes downwards, the spring follows, and at the 1 second mark, it goes all the way down. Let me just zoom in a bit. Okay, at the 1 second mark, all the way down, and then at the 2 second mark, goes once again all the way up. So I created the whole animation as you see it in just using a single parameter to control it. The other way is to use rotary motors, and rotary motors is when you want something to rotate indefinitely. Okay, so I can also do that. It's not going to be easy to do it using dragging, but with mates, I can have like a limit distance mate from 0 to 390, 59.99999, because SolidWorks doesn't like it when you do one whole rotation to the exact same part you started from. So that would work, but that's only one rotation. If I want multiple rotations, it's going to be a bit tricky. So that's where the motors come into play. So I'm going to start a new motion study. And once again, a new motor, rotary motor, the direction, let's say this axis. I've got the arrow over here. Since this is floating in midair, I don't really have anything to move relative to, so I'm just going to leave that as it is. And then for the constant speed, this is RPM, rotations per minute. So if I want it to be rotations per second, it's going to be times 60. So like 60 RPM is 1 rotation per second, divided by whatever duration you want it to be. So if I wanted to do 1 rotation, let's say in 3 seconds, so it's 60 divided by 3. If I wanted to be in 5 seconds, so divided by 5. Once again, I don't do any maths in my head. I just tell SolidWorks, here's the equation, you solve it for me. So here's the rotary motor. It's going to end at 5 second mark. That's fine. I'm going to hit calculate. And as you can see, it's now going to calculate the whole process for me. One thing to note, I actually don't have separate components for all of these. These are actually sub-assemblies. So if you look at my feature tree over here, these are all sub-assemblies. But because they're made flexible sub-assemblies, I can now animate them inside of the top level assembly. So as you can see, all of the components are moving in sync like that. And once again, here's the feature tree. I've got all of these sub-assemblies that have got the components inside of them. So as long as they're flexible with this icon that you see over here, it's now able to move freely. Just a quick note, if you just like click on one of these, from the context toolbar, this one, here is how you change it from flexible to rigid, okay? Just a quick note. So that should be it when it comes to animations, whether it's using key points or using motors. Okay, now let's see the next part of it. But actually, that's not really it, because there is another one, a hidden technique to use animations, which is called the animation wizard. And the animation wizard, as its name indicates, it's a wizard. It's got some trickery involved. And the main thing here is that it's doing things that you can already do inside of SolidWorks, but in a quicker or a faster way. Okay, so let's say, for example, you want to create a turntable animation. That's a pretty reasonable thing that you would want to create inside of SolidWorks, where you have like the model, and then you look at it from 360 degrees. You just like take a full 360 view around it. Okay, so let's create that inside of SolidWorks. Let's really quick open the model. So here it is. I've got this model, and I want to create a turntable animation around it. Before I start, let me just open the clock application, and I want to do it racing against time. Okay, so let's see how quick I'm going to be. Let's open a stopwatch. We set it, put it over here in the corner, and then I'm going to explain later. But first of all, let me just create the whole animation, and then we're going to talk about how I created it after. Okay, so ready? 3, 2, 1. I'm going to create a new motion study. I'm going to go over here to the animation wizard. Next, 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 finish, and done. In under 6 seconds, I've created the turntable animation. You don't believe me? Let's look at it. I'm going to hit play. And as you can see, I've got the 360-degree view of the model. Maybe it's not the best looking one, but believe me or not, it is a 360-degree view. So one might notice that there are multiple wrong things going on. Let me just close this for a second. So first of all, if you look at this y-axis, I'm supposed to be rotating around the y-axis, but for some reason the y-axis is rotating with me. And also, I'm looking at the model right now from the top. at some point I look at it from the bottom, and then it's just really weird. It's inconsistent. But that's not the only wrong thing about it. So what happens is that SolidWorks just adds these different key points at various intervals, and then just tells the software to move from one to the other. And the problem here is that, let's say I want to edit it. So instead of being 10 seconds long, I'm going to come back over here to the animation wizard, and I'm going to say rotate model. I'm going to hit next, rotate about which axis, which direction, which number of rotations, everything. I'm going to leave it as it is. And then the whole duration, let's say I want it to be 7 seconds, start at the 0-second mark. I'm going to hit finish, and it adds them on top of the previous ones. So now if I hit play, I'm going to end up with this gibberish. Okay, so there's a solution, don't worry. But before that, I don't just want it to do like a 360 view. Maybe I also want it to like hide a couple of components here and there. So maybe I want to hide this one. Okay, and then maybe at the 6-second mark, I want to hide this one. So I'm doing other things as well as the 360 view. And now when I come back again to the animation wizard, there's an option here called delete all existing paths. So that's cool. Let's use that one. Hit next. Maybe this time I want it to be at 5 seconds, and then start from the beginning, hit finish. And as you can see, it has deleted everything, even the other things in my animation. So if this is the last step that you created after you finished everything with the animation, and then you wanted to edit it, don't ever use the delete all existing paths option, because it's going to delete literally everything. So there's a solution to that, but it's going to need a bit more prep. So I created this sketch over here. It's just a circle in air. And then this circle, as some of you might have guessed, is going to be for my camera. I'm going to add a new camera. For the target, I'm going to go with the origin. I know that the origin is a bit too low. Let me see. Yeah, it's a bit too low. So maybe show numeric controls and go to 25. That's a bit too high. So divide by 5. Yeah, perfect. That's like exactly in the middle. And then when it comes to the camera position, instead of specifying a value, I'm just going to select this sketch. Look at what happens to the camera. Now the camera is on that sketch. And not just that, I also have this slider. So when I slide this from left to right, the camera starts moving from left to right. And just like that, that's how I get the turntable animation. The last thing to do is just to change the aspect ratio, maybe do it at 1:1. And yeah, that's pretty much it. So I'm going to hit OK. And then let me just change this to maybe something like that. I'm going to go back again to the motion study. And then from the 0-second mark, it's going to be like that. At the 5-second mark, I'm going to open this, edit the camera properties. All I have to do is just to drag that slider from left to right. Hit OK, and that's it. So when I hit play, as you can see, there it is. If I want it to be like 10 seconds long, I can just drag this. There it is. It's now 10 seconds long. It's going to play from the beginning. It's 10 seconds long. If I want it to be 2 seconds long, I can just drag this, put it like that, play. It's 2 seconds long. So just like that, it takes a bit more time to prepare everything, but the result, it speaks for itself. And if you don't believe me, don't take my word for it. Look at this side-by-side view of it. Obviously, this is like much high quality with shadows and everything. The one on the right, this is the one created with the camera. The one on the left is the one created in under 5 seconds or 6 seconds with the animation wizard. You get to choose which to go with, but in my personal opinion, the one on the right wins by like, there's no comparison. It's way better. Okay, so this is when it comes to the turntable animation. Now let's talk about exploded views. So I'm going to use the exact same model as an example over here. So I already have my exploded view created. So if I go over here to the model and to the configuration manager, I've got this default configuration. I've got the exploded view created. So I can right click over here and hit animate explode. It's going to animate the whole exploded view process. And if I pause it, I already have the save animation button over here. But this is only going to save the exploded view. Let's say I actually want to import this explode view inside of the animation and do other things as well. So this is where the power of the animation wizard comes. So I'm going to come over here. Let's just put this back again as it was. Maybe that looks a bit better. It's just a bit glitchy today. And what I want to do is just, I'm going to go once again to the animation wizard. I'm going to go to the explode option. Hit next. The duration, let's say 5 seconds maybe. Okay. Let's make it 4 seconds. And I'm going to tell you why in a moment. So there it is. It automatically introduced all of these different key points for me. Okay. And just like that, let's say this is 4 seconds long, maybe, if I hit play. So I'm not only am I doing the turntable animation, but I'm also exploding at the same time. And let's say I want it to stay still for 1 second, so that's at the 5 second mark. And from here, I want to collapse it once again. So do the opposite. Also 4 seconds long. Start time is 5. Finish. There it is. And then I'm just going to make this animation 10 seconds long to have 1 second pause at the end as well. So it's like mirroring what I started with. Okay. And now when I hit play from the beginning, it's going to calculate the exploded view. The turntable animation is still happening. It's again going to calculate the collapsed view. And it's all in one seamless animation where it just explodes while it's rotating, stays still for a moment, collapses. And it's just really cool. Way better than just a regular exploded view, or way better than a regular turntable animation, because I combine both of them at the same time. And once again, I can easily just drag this along to change how long this exploded view is going to look like and how long the turntable animation is going to take. Okay. So now let's talk about the last thing, which is the mate controller. And mate controllers, for those of you who don't know about them, it's as the name indicates, it's a way to control mates. It was introduced back in 2016, so it's like 8 years ago. But for some reason, people don't use it as they should because it's really cool. So I'm going to go over here, insert mate controller, okay? And then I'm going to select the mates that it supports to control. It doesn't support all types of mates. I'm going to talk about the types it supports a bit in a moment. But right now, there's this cool button which says collect all supported mates. So if there's any mate that it supports, it's going to collect it automatically for me. And forget about the naming. These are all limit angle mates for these 16 chair pieces over here. I just renamed them. But the cool thing is I've got these sliders for every single one of them that I can simply just drag along, just like that, to change the position or the value of every single one of them. So all I have to do now is just create a new position. Let's say position 2. And now using the keyboard, the number pad and the tab button to move. So tab and shift tab moves you from one to the other. Okay, so this is what I'm going to do. Let's say I want it to be all of them downwards. So 0 tab, 0, 0. This is all I'm doing. Just hitting 0 and tab on my keyboard. And just like that, I've got everything changed all in one go. Just going to hit update. And there it is. So this is position 1. This is position 2. If I create a new position, position 3, it's going to be a duplicate of position 2. And then let's say I want one up and one down. So I'm going to come over here and say 45, tab, tab, 45, tab, tab, 45. In no time, I am creating an animation like that. Okay. And remember, so this is position 1, 2, and 3. Let's say the final position, position 4, I want everything to go back up again. Remember when I created position 2, it was a duplicate of position 1. Position 3 was a duplicate of position 2. So if I go all the way back to position 1, I don't have to manually enter all the values to be 90 again. I can just create a new position from over here. It's going to be called position 4, but it's going to be put at the end. So 1, 2, 3, 4, and it's going to be a duplicate of 1. So here's 1, everything's down in 2, 1 and 1 in 3, and then at 4, everything comes back up again. It's really cool. And if you, at any time, you want to reorder things, you can use the reorder positions to change where everything is. So I can change where the components are. I can move them up or down, stuff like that. I can rename them or delete them. Everything can be done from this reorder positions dialog box. Okay. Oh, SolidWorks is hanging up again. It's really frustrating today because and it crashed.
Yeah, it's being annoying again and again. It's
Yeah,
the hectic for you.
I need to update my graphics card driver I know that, but that's why it's glitching today. Why did I have time to do that earlier? So yeah, I'll have to remember to not present without updating my graphics cards later on.
Which graphic card do you have now?
It's an NVIDIA graphics card. So let's
Oh.
reopen the model real quick. So just for the sake of time, I'm not going to recreate the animation. I'm just going to play an animation that I've already created with this type of thing. So what I have to do is just when I'm in the motion study, I just hit the animation wizard once again. And now I've got this mate controller option at the very bottom because this animation has a mate controller. Explode and collapse are grayed out because I don't have mate controller inside of them. But there's one thing to note over here, that if I go over here to the mate controller and I edit it, you're going to notice that at the very bottom, I find these durations. So right here is where I set the duration of every single transition or every single interpolation from one position to the other. And this is really important because when I import everything inside of here, I select the mate controller, import it as key points because this is an animation, not a motion analysis. Hit next, and I don't get to set the duration because it's already got the duration from the mate controller itself. Now all I have to do is just enter the start time, hit finish, and if I scroll all the way down, and since this is mate controller, so these are all different values for mates. So as you can see, all of these different key points are added for me. And you want to see what this animation looks like. It's really cool, by the way. Here it is. So these two armrests come down, and then they come back up again. And then you know the wave motion? So it does this wave motion, then it comes back up again. It's really cool. But remember, if I want to do this manually, it's going to take a long time to be able to edit every single dimension and then change its value and so on. But using the mate controller, it's done like this. I think this took like less than 5 minutes to create because once again, I've got the 0 degree position, I've got the 90-degree position, and all I have to do is just say, okay, I'm going to divide it by 1/16 or something, and then here's the new angle that you want to do. I'm just like going to subtract 1/16 of the 90-degree angle, and that was really cool to do just with the keyboard and hitting tab and changing from one position to the other. It was really quick, as you can see. Okay, so now we have truly finished the animation techniques. I'm just going to do a quick recap. So the animation wizard, we talked about how it can save a lot of time. Now let's talk about the different types of mates that it supports. So all the mates that it supports have to have some numeric control in them. So things like the angle, the limit angle, the distance, the limit distance, the width mate, the path mate, and the slot mate. All of these can be controlled with a value. Unlike like coincident mate, there is no value to control over here. But remember, the width, the path, and the slot mate, they have options that you can select. The free option, for example, makes it move freely. That's not supported because there is no value with that. For the width mate, for example, there's the center option where it centers it exactly in between its boundaries. It also doesn't support that because there is no numeric control. But if you're using like a percentage control or a dimension control, that's what it's going to support. Okay, so this is it with regards to the animation wizard. Okay, and now let's talk about the basic motion options. Okay, so there are different techniques when it comes to basic motion. You've got contact, gravity, you've got different things to use. So now let's head inside of SolidWorks and see how we can create something like that. So I've got this model over here, and this is a wave motion simulator. So what it does is I've got this handle. When I rotate this handle, these cams would push these rods up and down. And then these rods over here, I would see a sine wave. And over here, I would see a longitudinal wave. So this is a traverse wave, and this is a longitudinal wave where I've got like compressions and rarefactions, something like a sound wave, for example. So it's a really cool device. I saw it at the physics lab at my school. So I want to recreate this inside of SolidWorks. I can obviously recreate it with an animation, but let's do it with basic motion to do like some real life physics in it. So I'm going to create a new motion study. First things first, just to make sure that I've got no mates in it, I've got this folder of tangent mates or like cam mates. I'm just going to suppress this just to make sure that there is no effect of these mates in here. The other mates, these are all just for positioning and stuff. Okay. So now all I have to do is just, let's start by adding the motor to this part over here and to this component. Okay, let's see the direction like that. And then for the relative to, I want it to move relative to this stand. For the speed, let's make it something like in 2 seconds, so 60 divided by 2. It's going to do the whole, well, like one full rotation in 2 seconds. So I can just come over here. Now it's rebuilding because I accidentally clicked over here at the in the time. So when you click somewhere, it's actually going to rebuild until that time. So that's something to take note of. Anyways, just want to end this at the 2-second mark. And remember, so right now, since there's nothing to link those two together, when I hit play, this is just going to rotate and everything else is going to stay exactly where it is. So now I want to introduce contact between these cams and these rods. So here is the contact button. So I'm going to click on it. And the first thing is I've got this menu over here, sorry, this message over here. It tells me the tool that you've chosen requires the use of basic motion or motion analysis. So now, since we're still in animation, I can use this drop-down menu to change to basic motion. Now everything's going to work perfectly. So I'm going to just select the components that I want to have contact between. I can go like bonkers with it and just select everything, but I want to minimize the calculations as much as possible. So I'm just going to select the rods and the cams in this case. Since I already have mates in place to fix the rods in position and everything. But if I want to do like a real simulation, I would have these rods to also be calculated against the stand and everything. Anyways, I already have like 561 contact pairs to be calculated, and that's a lot. So I'm going to hit OK. And as you can see over here, there is the solid body contact. Okay. Now, all I have to do is just hit calculate and call it in, right? I've got the motor rotating the cams, and I've got the cams with contact with the rods. So it's going to push them upwards, and that should be it. It's going to take a bit to calculate because, as I said, there's a lot of calculations. But what is going on? Okay, that looks really cool. So it's going to play. It's going to push the rods upwards, but I never told SolidWorks to push them downwards once again. So the rods are just keeping going upwards as it goes. So this is where we actually need to introduce gravity. So before I introduce gravity, let me just change the background to white, and you're going to know why in a second. So now here's the gravity property manager. Want to hit on it? I see gravity, and gravity it's got two things. It's got the direction, and it can be in any direction. So right now the direction is along the z-axis for some reason, as you can see over here. I can change it to y. Maybe I want gravity upwards for some reason, and let's just keep it downwards. And here the second parameter is the acceleration, the g. So right now the default is 9.8 something, which is the acceleration for Earth. But if I want to, I can do it like for Mars or for Jupiter or something. Anyways, right now let's just keep it to Earth. I'm just gonna hit OK. And just like that, I've got the gravity, I've got the solid body contact, and I've got the rotating motion. And now I've got everything in place. So if I hit calculate this time, everything should work perfect. So the rods are going to be pushed upwards due to the contact, and then they're going to come back again downwards due to the gravity. So just like that, as you can see, I've got the motion going on, as you can see. Everything's moving smoothly, and it all looks cool. So that's really cool and everything. But remember, 561 contacts, that's a lot. So I can actually work on reducing that number down a bit more. So instead of having all of these contacts in a single contact feature, I can introduce something called contact groups, okay? And what a contact group does is, let me highlight it, it tells me over here, contact between items in the same group is ignored. So now I have two groups, two boxes to enter components into. Let me just clear all the selections. Anything in the first box is not going to be calculated with itself, but it's going to be calculated with things in the second box. So for example, I already know that these cams would never collide with each other, and these rods would never collide with each other. But I only want to calculate the collision between the cams and the rods. So in that case, I can put all the cams in one box. Let me just change the background once again to dark mode. So all I'm going to do is just put all the cams in one box, put all the rods in the other box, and that means that it's going to cut down the number of calculations that it's going to do. So here's the cams all in one box. And the second box, I'm going to put all of the rods. And just like that, let's see how many contact pairs. 289. That's like a close to 50% reduction. Okay. And I'm going to hit OK. And I can recalculate and do the same thing, but just for the sake of time, I'm going to show you a side-by-side view of the results. So you're not going to see any real difference. All that's going to change in this case is the time it takes to calculate it. So ungrouped versus grouped, it's pretty much the same thing. You won't notice any difference between them. But once again, the main goal here was to reduce the solving time, not to reduce, not to change anything in animation. Because remember, right now, all the things that were going to be animated against each other and collided with each other, and then that collision would be considered. That didn't change in this case. I didn't choose anything that was going to be colliding, but won't be in this case. So that's the whole difference. Okay. And then this is pretty much it when it comes to solid body contact in basic motion. And I also introduced gravity as well in this area. And one thing to note when it comes to gravity is that you only have one gravity element in your animation, or in your timeline. Okay. So as you can see over here, once again, back to SolidWorks, I've got rotary motor 3, I've got solid body contact 2, but I only have gravity. There's no gravity 1, 2, 3, and so on. I can add multiple contact properties, but I can only add one gravity property. Okay, and the main thing is that any motion in a direction opposite to the gravity would win. So if there's a motor pushing something upwards and the gravity is pushing it downwards, it's going to move upwards because of that motor. Okay. So that's something else to consider as well. Now, what I showed you earlier, it was ways of creating something that can be created inside of animations or created inside of basic motion. But there are other cases where you can only create it inside of basic motion. There is no way to do it inside of animation. Okay, so for example, you see, this is like an hourglass shape where you've got these balls falling downwards, and then they have to be calculated against each other, and then and that would be run as a simulation. Or the one on the right, for example, you've got, this is like the Thomas Young's perpetual machine, where these balls would roll downwards while this is rotating, and it keep moving on and on and on. And this is something that you can't actually animate inside of animation at all, because you can't predict the path of every single one of these balls. You can only do it in basic motion, because that's the way you would predict all of them by calculations, right? And this is the main goal. Sometimes you don't have the option to choose whether you want animation or basic motion. You can only go with one of them. Okay. So that's pretty much it when it comes to exporting. Is the next step for now. So exporting is like taking all that we've created from SolidWorks and exporting it to show it to others. And when it comes to exporting, there are different things to take into consideration. The first thing is, as you saw with the model with the spring, or for these models down here, the pole and ratchet, if there's something changing in the CAD model, in the geometry itself, that would mean that it's going to be rebuilt on every single frame. That takes a bit longer, but that's only supported with animation. You can't do that in basic motion or in motion analysis. And if you want to render your animation using Visualize or with PhotoView 360, if you're using an older version of SolidWorks, you can also not do that. You have to use the SolidWorks renderer to have this like changing of geometry inside of a animation. Okay, and now let's talk about different things to take into consideration. So the first thing is, you don't only have to save them as a video. You can also save them as a series of images, like single frames, okay? And that's really useful if you want to do some image editing, or like graphic designing on some of the videos. Maybe you want to save them as a GIF, and yeah, I call it a GIF, not a GIF. So if you want to create a GIF from the images, you can also do that, and so on. So for example, here's, if I go and open my LinkedIn profile real quick. One really cool use case of this is that you saw this hourglass shape animation that I showed you a bit earlier. I created one that's a bit more graphically intense. And that one, there was like a moment in the middle that was really cool, and I wanted to show that to people. So there it is. So I wanted to just export that still moment in time, okay, at the middle. So to export that moment as it is as an image file, I saved it as an image, not as a video, and then take that image from the video. So that would make it really cool to be able to export just a single image, or like even a series of images, but just as image files, not as a video file from SolidWorks. Okay, and once again, this animation, it's done with basic motion, as you can see, because there is no way I could actually expect myself to know where every single ball of these is going to go. You know, they're just all going downwards. They're mashing and hitting each other and colliding, and then they just go where they're supposed to go at the very bottom. So that's something that you just simply can't do with animation. Okay. Next thing is resolution and FPS. So resolution is we talked about aspect ratio, which is the ratio between the width and the height. Resolution is a bit similar, but it's the value, the number of pixels in the width and the number of pixels of the height. So let's say if I've got an image that's a bit small and an image that's big, the difference between them is how many pixels they've got. That's based on the resolution. The same thing happens with videos. So a high resolution video would be something like 4K or like full HD, which is like 1920 pixels by 1080 pixels. If you want it like a bit smaller, HD, that's 1280 pixels wide by 720 pixels high. So that's the resolution. The more pixels you add, the higher the resolution is, and the clearer the image is. You get a better or a higher quality. FPS is frames per second, and that means how many frames does the video include in every single second. And the higher that number is, obviously the video is going to be a bit bigger, but that also means that the movement, the motion is going to be a bit smoother because you have more details in the video, which means that you can now see small movements a bit more clear. Okay, so the last thing we're going to talk about is video compression, because this affects not just the exporting times from SolidWorks, but also the file size that you end up with. So let me just showcase all of this real quick. So the video that we're going to work with, and we're going to export it in 3 different ways, and we're going to compare the file sizes and the video compression of all of them. But now remember, it's the same video. The one on the very left, this is uncompressed AVI. AVI is the default file format for now inside of SolidWorks. The one in the middle is fully compressed AVI. And remember, these artifacts that you're seeing on screen, this is not because of SolidWorks glitching or PowerPoint glitching or because the internet connection isn't strong. This is glitches inside of the video itself from the fully compressed AVI. And then you've got the MP4 on the left, on the right, which is, to me, pretty much the same looking wise as the uncompressed AVI. So now let's see how we could create something like that inside of SolidWorks. We're going to export these animations. So I've got the motion study already over here. Okay, I only want to export it from 2-second mark to this 4 point whatever. So I'm going to hit save animation, and then I've got the data box. So if I go over here to the desktop, and here's the file format. So these first 4 ones, AVI, MP4, FLV, and MKV, these are video file formats. The series of something, these are image file formats. So you've got series of bitmaps, JPEGs, PNGs, and so on. Let's say, for example, I want to save it as a series of PNGs. You know that PNGs, sometimes they can support transparency. So if you've got in the export options inside of SolidWorks, transparency settings for PNGs, you can actually export your animation as single frames without a background, without this dark gray background that I'm using in the background over here. That's something you might want to do. For now, let's just go with AVI. So here I can select the file size, the image size and the aspect ratio. The aspect ratio is right now set using the camera. So I can select a custom one, let's say 16 by 9. And in that case, if I go with 1280 by 720, that's HD. If I go with 1920 by 1080, that's full HD, and so on. The frames per second, for some reason, the default is 7.5 for now. Don't use that. Just never use that, okay? You can use anything. You can use 24. Some people like using 24. Some people like using 30. I like using 30 a lot. If it's like a detailed animation with very small changes that happen really quick, I would go with 60. Like with the animation you just saw a moment earlier, where I've got all of these balls doing these very small changes in position, and it's all happening very fast. I use 60 frames per second for that. Some people actually use like 29.97, which is like the standard for TV in America or something. You can use that, but just don't use 7.5 because that's very, very low. Okay, obviously I'm joking. 30 is like the sweet spot for me. And I don't actually have to export the whole animation. I can just export a certain time of it. So let's say a time range, let's say from 2 seconds to 6.1 maybe, or a single frame. That's really cool if I want to save like an image or something. I can just export a single time frame. For now, let's just export 1 second. So from 0 to 1. Okay, and I'm going to hit save. It's going to now ask me for the video compression. Which compression codec do you want to use? The engine that's going to do it. If I choose uncompressed, that's no compression at all. I have multiple compression engines over here. I can change the compression quality. The default is at 85%. There it is. If I hit OK, yes, and then it's going to go ahead and do the compression for me and export the video from 0 seconds to 1 second. Quick note, if I hit stop, it's not going to end up with the correct video. It's actually going to export from 0 to this half second or something. It's just going to export that time duration. And if you don't believe me, well, there it is. If I go to the desktop, here's the video, and it's actually just like half a second long. Okay, and let me do the exact same thing, but with an MP4 this time, because this is what we want to compare it against. I'm going to do the exact same thing. Let's say 1920. Don't use the aspect ratio. No, I'm just going to enter it manually by 1080, 30 frames per second, everything is fine. And if I hit save, it's also going to start saving. And once again, if I just hit stop, it's only going to save that part that it created until that point. Okay. Same thing if I go with images. So if I go with a series of, let's say, PNGs. Okay. And let's go with something smaller. So 2080 by 720. Okay. Let's just do like one single frame. That's going to be an image. Time range. This is the cool thing. So if I go 0 to 1, that's 1 second. If I do it right now, it's going to save me 30 images. That's a lot. So let's just go with like 10 frames per second. Don't save your animations as 10 frames per second. I'm just showing you right now to see how it's going to do. But in real life, 10 frames is very, very low for an animation. So it's also going to do the exact same thing. But if I go over here, as you can see, it's just saving every single one of those images as it goes by. Okay. And there it is. I've got the images over there. So now let's compare them. Okay, I've already done the comparison, so let's just look at the results. The uncompressed AVI on the very left, it's 4 seconds long. It's the same animation for all of them. It's 292 megabytes. That's like over quarter a gigabyte. It's a lot for 4 second long animation. The one in the middle, fully compressed, it's 1.5 megabytes, way smaller, but the quality way rubbish, right? So the MP4, oh, look at that one. Same 4 second animation, pretty much the same quality to me. When I look at it, when I compare it to the uncompressed AVI, it's 23 kilobytes, not megabytes, kilobytes. It's like a different unit of measurement. So this changed. All that changed. It's just the file format from AVI, MP4, and MP4, as you saw when I was exporting, it didn't even ask me for the quality or the compression because it does all of that behind this for me. So it just balances this quality and this file size thing. So it just does all of that for you. And the end result speaks for itself. So personally, ever since SolidWorks introduced MP4, I think that was in 2018 or 2019, I've been using MP4s on its own, nothing else. Sometimes I use images, but when I'm exporting videos, I would always use MP4s because, as you saw, the file size is a massive bonus that, I mean, storage on our devices is not, right? So that's pretty much it for our session today. I know that we've covered a lot of topics today. It was a pretty much dense session. I'm gonna go right now and check the questions in the chat to see if anyone has any questions for me. And if you've got any questions after I go through those, also put them in the chat. quick note before I just go into the chat. If you have any questions in the future about animations or anything related to SolidWorks, feel free to reach out to me on LinkedIn. I'm always active over there. So I've got an open profile. Anyone can send me a message. Just send a message. Tell me, hey, I was in this session with Sayed and the Hyderabad user group meeting, and here's my question. Or it doesn't even have to be a question. If you create an animation and you want to share it on social media, feel free to tag me in the post or share me the link. I would love to see the things that you create and see how useful this session was for you guys. So with that being said, let me now go through the chat because I saw that the chat was really popping throughout the session. Let me just go and see the questions that we have. So yeah, Arjun here is saying that he didn't believe that the animation I did, the scrolling animation from the Facebook post was made in SolidWorks. Yeah, it was a really cool idea. Prasad is saying it's the new video editing tool. Yeah, I mean that's what I'm talking about. Having to having the knowledge of how to use these tools inside of SolidWorks and just using them however you want to it is the way to go. You know, I'm not telling you guys to use motion study as video editing, but still it's it's really powerful to be able to do something like that inside of SolidWorks. Let's see what else. So we all have a question here. Stop or just pass through. Looking at the time, it's an animation. I think that question was regarding the chocolate bar. So since that was an animation, there is no contact in animation. So in that case, SolidWorks has no problem intersecting or like interfering components together. It would only stop if you specifically told it that here's a contact between this component and that component. So if I'm in basic motion or motion analysis and I don't add contact, it's also going to cause interference. Only when I add the contact is it going to stop and collide the two components together. So let's see what else. Someone was talking about which graphics card is good for large assemblies. Well, definitely a graphics card that's certified. So if you go to, if you Google like SolidWorks hardware requirements, and you're gonna find the list of supported or like certified graphics cards for SolidWorks. Usually it's the AMD Fire Pro series or the AMD Radeon Pro series. And from NVIDIA, you've got the NVIDIA Quadro series, you've got the NVIDIA RTX Ampere series. So it's RTX A 1000, 2000, 4000, and so on. And also the new RTX Ada generation series. So these are all different NVIDIA GPUs that are really good for SolidWorks, and they are certified by SolidWorks to work with it. So yeah, I think that we've covered pretty much all of the questions right now. As I said, once again, if you guys have any new questions for me, feel free to send them over on LinkedIn. I would really love to hear back from you guys. And with that being said, over to you, Sayed.
Wonderful sessions. Yeah, wonderful. Yeah, even I learned a lot of things today. Like those cam animation was just amazing. That blew my mind. Like it was like fire. Wonderful. And for that, I would like to present you with something I prepared. I would like to present you with this certification of appreciation for being the very first speaker of our user group. I hope you will accept it.
That's really kind of you. Thanks a lot for that certificate.
I'll mail you the high quality one. Okay.
Yeah, sure. I would love to share that with my. I mean, you know, at some point you get a lot of certification like the CSWE and stuff like that. But these are the certifications really I am proud of because of how much, you know, this engagement in the chat with you people and having Prasad and you said and other people in the chat. That was really fun. So thanks a lot for inviting me over.
Definitely. With you being the first speaker, I feel rest assured like there's this someone I can trust to be the first speaker of our group. Like I really appreciate you for being in touch with them throughout the whole process. Like you know how long we have been planning for this event.
Yeah, it took a lot. It took a lot, but I'm really glad how it ended up working. I mean, SolidWorks was a bit angry in the middle, but we went through. We made it through.
Yeah, definitely, definitely. So if there are no questions, let us end the meeting. Looks like there aren't any. So, okay. Bye, yeah. Hope for
Bye
better
bye.
future. Bye.
See you in the future.